Hello?
Hello? Goodbye.
Hello? Alright, okay. So, local extrema and concavity. So, extrema, that means extremes, right? Concavity.
Something.
When it opens up.
Okay. Or
No.
down.
Yes.
It's kind of like a cave in. It's concave in, right? Or concave down, right? It's cave in.
Oh, isn't it like concave and convex? Like convex up and down.
Yeah, convex would be something different though.
Oh.
But we're just talking about concaves. All right, first derivative test. Okay, look, I'm gonna explain all this right here. I know this looks like something you see on like a space station, the Roswell, New Mexico crash. It's actually really not that bad.
New Mexico crash?
Yeah. You know there's like a spaceship that crashed here at Roswell, New Mexico, right?
No.
So what?
Yeah.
No.
Anyway, all right. So, okay. Suppose C is a critical number of f, and a to b is an open interval. Open, remember? Open. Okay. Open interval there. F prime. So that means the derivative, right?
Yeah.
The derivative of x is greater than 0 in the interval from here to here. Okay. And the derivative is less than 0 from c to whatever b values, then it's going to be a local maximum value. Just think about your slopes. If the slopes are actually going up, then all of a sudden at some point it goes down, that's going to be a maximum, isn't it? That's what it means. That's what it's saying. If the slope keeps going up to a 0, then after that 0 it goes down, then that's a maximum. So what do you think the next one has to do with? If it goes from a negative, right? Negative slope in that interval to a positive slope, so a negative slope to a positive slope, right there it's changing, that's going to be a minimal. If f prime has the sign same sign on both sides of c, that's neither local maximum or local minimum. So it's kind of like this. So right here it goes to 0. If you look, it's positive, positive, positive. Right here goes 0, positive, positive, positive. So that one's neither min or max. Okay, does that make sense? All right, words, C is a critical number. F of F, and F is increasing on the left of C and decreasing on the right of C. Local maximum value, F is decreasing, left of C increasing on the right, and it is a local minimum value. Okay, so here. All right, let's take a look. Increasing, decreasing, local max. Decreasing, increasing, local min. Make sense? Did I lose anyone yet? I'm working on it. I'm trying to. No cheating.
Excuse me.
Find the local extrema. Okay, so now.
You don't say no.
Who what?
You didn't lose me. It was just a question, but.
Hello?
Are we gonna? Wait, is the homework due? Like, can it be due later this week?
Do you want it? What homework?
4.3.
Huh?
4.3.
4.3. What do you want to do?
Like, can it be?
Do you say you want like Wednesday?
Yeah.
Wednesday is good, my dude.
Okay.
Okay, good. All
It should be due.
right. Okay. Find local extrema. So first thing I'm going to do is do what? Take the derivative, right? So let's take the derivative. So it would be f prime of x is equal to minus what? There we go. So there's the derivative. Now, from here, I need to figure out the critical points. So, and I have to do the first derivative test from there. So, set this equal to 0. Set it equals 0. So now 0, 4x cubed minus 12x squared. Now, you should look at that and say, F that, right? F that. So what are you F'ing out? 4x squared, right? 0 equals 4x squared, parentheses, x minus 3. So, right here, zero product, I get two answers. X equals 0 and x equals 3. Okay, so I have two places in which that this is going to be equal to 0. Okay. All right, 0 and 3. So we're going to test this. So we're just checking for positive and negative. And the easiest way to do this is to use this right here. Use this right here, and we're going to plug in there. You can plug in the derivative up here, but this is actually works out a whole lot easier. You'll figure out why. Let's pick negative 1. With negative 1, what's going to happen out here?
Negative.
That's a positive, right?
Yeah.
That would be a positive. So over here, negative 1 would be it'd be a negative, right?
Mm-hmm.
So this would be a positive, and this would be a negative. So when they multiply, I get so that's for the entire interval from negative infinity to 0. Okay, does that make sense? You guys see why we actually plugged in there too? All right, the next part in my interval, pick a number. 2. Okay, let's do 2. So at 2, this is going to be, that's positive, right? All this is going to be
It's negative.
all right, pick another number. 5. So at 5, this right here is going to be positive, and this is going to be, so my answer is so negative, negative, and then positive. So what does that tell me about the point 0? They're same size, right? So if it's going down, down, so it would look something like this. So it's actually going down, down, down to 0. And then it goes down again, right? And then from here, it goes back up. So I tried to line it up here. So that's 1. That's 3. Okay?
Why wouldn't it just be like a straight? Why wouldn't it just stay like that?
Right here, it's got to go to 0.
Oh.
It's got to go to 0 here because that's a place in which my derivative is equal to 0. So the slope is 0. Okay?
Oh, okay.
The slope is 0. So let's take a look, and I'm going to show you what the function looks like. Doc B. Let me clear this. All right. What was the function in the first place?
X to the 4th minus 4x cubed.
Okay, here we go. There it is.
So basically, just as 0, is it gonna be like that?
Yeah, there we go. See, add 0. It's going down, down, right?
Yeah. I mean, yeah. Okay.
Do you guys see it? So add 0, it's going down, gets a slope of 0, and then starts going down again. And right here, this is where it's at the number, what number was it? 3. It's going to be here, it's going to be 0, and then it goes up here. Does that make sense now that we see it?
Couldn't you just trace it?
Huh?
Couldn't you just trace it? Like menu trace.
Oh, I could.
And just
Do you want me to?
You don't believe us.
But right here. Don't forget, this is I'm talking about the slope now. I'm not talking about the position. So the slope. So yes, it is 0, 0, and the slope is 0 here. So if I'm looking right here, all this is going down, right? So that's a negative slope. And right here it goes to 0. Right? The slope is 0, so it has a horizontal spot. And then again, it's going down again. So it's going down on this side. Okay? So, yes, you could go through and trace and all that, but guess what? You gotta have to be able to do this on the without the calculator. All right, does that make sense?
What is the local extrema with that?
Okay, so now you tell me. Is there a local maximum?
No.
No. For it to be a local maximum, what has to happen?
I
From
just thought because
increasing
it was
to
asking,
decreasing.
so
Yeah.
I know like I couldn't see it.
From
That's why I was
increasing
like-
to decreasing.
Okay, so a local maximum value goes from increasing to decreasing. Is there any spot there it's going to go from increasing to decreasing?
No.
No. So that there is no local maximum. But if it's going from decreasing to increasing, decreasing to increasing right here, this is a local min. This is a local min right here.
Yeah, but if it was only decreasing or only increasing, so there's no maximums and minimums at all.
Yeah, this one has an absolute, like it goes all the way up. Goes up to positive infinity. Up to positive infinity. This would be the minimum. This would actually be the absolute minimum of the function too. So the entire function, the lowest point would be right here. Okay. All right, find local extrema of this. All right, so what rule is that?
The product.
It's product, but I could also distribute this, can't I? Because there is no exponent on that second part, I could distribute it. Isn't this going to be 3 over 3? Yeah. So when I multiply that, what do I do with my exponents?
Sum.
Add them, right? So it's going to give me x to the
5 over
5 over 3 minus 5 x to the 2/3. And this is my f of x. So this is before I even did the derivative, right? It's going to make it a whole lot easier. So let's go ahead and take the derivative. So this is going to be, so f prime of x is
x is
5/3 x to the
2/3.
2/3 because I'm subtracting 1, right? I subtract 3/3, so that's 2/3 minus 10/3 x to the -1 over 3, right? Because again, I have 2/3, but I'm subtracting 3/3. Okay, so let's go ahead and gotta try and set this equal to 0, but I need a common denominator to make that happen. So I'm gonna rewrite this. This is gonna be 5 x to the 2/3 over 3 minus 10 over 3x to the 1/3. I have a positive exponent in the denominator now. Yeah. Now I can make common denominator now, right? So multiply the left one right here by x to the 1/3, right? Okay, this is still my f prime of x. So I'm multiplying this one by x to the 1/3. So that's going to give me 3/3, right? So it's going to be 5x minus 10 over 3 x to the 1/3 is equal to my f prime of x. So I cleaned it up for a reason. It's going to make my math a whole lot easier. Did I lose anyone on this?
No.
Speak up.
What happened to the 2/3 next to that 5?
Oh, okay. So right here, see this? It's 5x to the 2/3 over 3. And the common denominator would be all of this, right? But doesn't it already have a 3? So I'm only multiplying by x to the 1/3 on top and bottom.
Like what happened to the 2/3? You see the 5?
Okay, so when you multiply fractions, what do you do? Or you multiply exponent. Multiply variables, what do you do with your exponents?
Let's play. Don't you add them?
Yeah, you add them. What's 1/3 plus
Oh,
2/3?
yeah,
There we go. It's 3/3. Yes.
Yeah,
Okay. Yeah. No worries. So, yes. Okay, we all right now? Just making sure everyone's okay, because whenever I do some algebra, you know, people like freak out and get all glossy-eyed. All right, so now set this equal 0. So I'm going to go over here. 0 equals 5x minus 10 over 3x to the 1/3. I like fractions because I can get rid of the bottom. Multiply both sides by 3x to the 1/3, right? And when I multiply that by 0, it just goes away, right? So now I got 0 equals 5x minus 10.
X is not equal to 0.
So x is equal to 2. Right? Add 2 to both sides, divide by 5, so I get x is 2, right? So, now, my issues. What type of exponent do we have here? Two-thirds, right? X to the 2/3. What does the 2/3 mean?
That means
Square, like third root.
It's a third root, right? So it's a second power and a third root. Is there anything not allowed in third roots?
No.
Everything's okay, right? You're allowed positive and negatives and all that, right?
Yeah.
Okay, so square roots, you're not allowed to have it, right? Okay, good. So let's take a look. Since I have all of that there, so let me see. Is there a place in which that I cannot do this?
X is not equal to 0.
X cannot equal 0, right? So I'm okay with the function equal to 0, right?
Yeah.
So f of x is okay to equal 0, right? But f prime of x cannot equal 0. Because right here, I cannot equal 0 there. Yes? So, when I cannot equal 0, that means I'm going to have a kink right there. That means it's going to be a pointy point in my derivative. I cannot take a derivative at the point. So I know that x right here equals 0 is also going to be one of those points. Okay? So I have different things on different sides here. So let's take a look. So I'm going to take, do I have another slide over here? No, not yet. Okay. Let's do insert, page, after current. So we say that, what was my function? What was it? It was x 2/3, x minus 5 or plus 5? Okay, so f prime of x was so 5x there we go. Okay. So I know that x, okay, for this one right here, a critical point x equals 0, and another one's going to be x is equal to 2. All right, let's take a look. Number line 0, 2. So let's pick -1. So if I pick -1, let's see, -1, so it's going to be 5, -1, minus 10 over 3, -1 to the 1/3. So all this on the top will be, help me out, on the top, that's going to be negative, isn't it? So that's negative. What about the bottom? Is everyone asleep?
Nope. It's just negative. And
That-
it's positive.
That's negative down here.
Yeah, it's positive.
So the whole thing is going to be
Positive.
positive. So I'm going to hit positive right here. All right, let's try 1. Try a positive 1 now. So on top, what do I get? A negative. On bottom, I get. So that makes this whole thing. All right, so what about the other side of 2? So that's going to be 3, right? So 5, 3 minus 10 over. So on top I get, on bottom I get, so the whole thing is going to be, so let's take a look. If it's changing from positive to negative, that means it's a
Extreme.
positive, yes. Positive to negative, that's going to be a what? It's going to be a max, right? So this is, so basically positive right here, and it's going down here. And at that point, it's going down, and it's going from negative to positive, so that means it's going up, right? So this would be a max. This is local max, and this right here would be a local min. Does that make sense? So I think this next one is actually the graph of it. Yeah, there we go. Okay, so I'm going to leave off here. We're going to pick up this again. So we have what? However long. Okay, work on homework, work on practice, and like and subscribe.